This is Catherine Nightingale at Chattanooga State Community College. This video is for Math 2110, Calculus 3, Section 11.4 on the topic of the cross product. In the last section, we talked about the dot product, which was one way to define vector multiplication. The cross product is another way to define vector multiplication, and it's actually calculated very differently than the dot product. With the dot product, you ended up with a scalar every time you dot product two vectors together. With the cross product, you actually end up with a vector as your answer rather than a scalar. To do a cross product, we need to know how to do a determinant of a matrix. So we'll start by defining that. A determinant is a number assigned to a square array of numbers in a certain way. In Calculus 3, we use the determinant to calculate the cross product of the two vectors. For a 2 by 2 matrix, meaning 2 entries in each row and column, what we do is we multiply down the front diagonal, so A times D, and then we multiply down the backwards diagonal, B times C, and we subtract the two, so you get AD minus BC. For a 3 by 3 matrix, what we do is we expand along the top row. The signs alternate, so I have plus, minus, plus along the top row. And what I do is I start with the first entry, and then I look at if I eliminated that row and column, what would be left over. So this lower right corner would be left over. So I'll have that first entry A1 times B2, B3 in the first row, C2, C3 in the second row. Now, what I do is I expand along the top. So remember, my sign alternates, so I'm going to have minus A2. Then I look at what would be left over if I eliminate that row and column that A2 is in. And so I get the minus A2, and I get B1, B3, C1, C3 as my matrix that's left over. Do that again for the third entry, A3, and then what would be left over? The bottom left corner. And so that's where I get my plus A3 times B1, B2, C1, C2. The cross product is the determinant with your standard basis vectors in the top row, your vector u in the second row, and your vector v in the third row. So this would be the cross product if I was doing u cross v. So the order matters with the cross product. The one listed first goes in the second row. Okay, if I expanded this using this rule that we just talked about, then what I end up with is u cross v equals the I component being u2 v3 minus u3 v2 minus the j component of u1 v3 minus u3 v1 plus the k component of u1 v2 minus u2 v1. So there's my definition of the cross product. Let's actually apply this with two vectors. Before we apply it, actually, let's talk about the direction. So u cross v is orthogonal or normal to both u and v. Now, these words just mean perpendicular, so a 90-degree angle. And if we look at these diagrams, this is what we call the right-hand rule. If you're going from u to v for u cross v, then you wrap your right hand around from u to v, and your thumb is pointing up, and so u cross v is pointing up out of the plane. If you cross from v to u, then using your right hand and wrapping it from V to U, your thumb would be pointing down out of the plane, so you'd have the opposite direction. you'd have the opposite sign. And so what happens is U cross V and V cross U have opposite signs. And that's always going to be the case. If you change the direction, it changes the sign. Okay, now first example, find a vector that's normal to U and to V. So remember, U cross V is normal to both U and V. So what I do is I put my ij and k in the first row. That's always going to be the case. I put U in the second row and V in the third row. And I want to expand. So I'm going to have my alternating signs, plus, minus, plus. Start with the upper left, so I, and then the lower right matrix, minus j, and then the first and third columns, plus k, and then that's the first and second columns. Now when I'm doing my 2 by 2 determinants for the I, j, and k, I'm going to have my forwards diagonal and my backwards diagonal. So 1 times 6 minus negative 1 times 4, I, minus 1 times 6 minus negative 1 times 2j, plus 1 times 4 minus 1 times 2k. Simplify this, we get 10i minus 8j plus 2k, or in component form, 10 negative 8, 2. The most common thing people forget is the alternating signs. You always have to subtract the j term. Alright, now we do have an angle definition when we talk about the magnitude of the cross product. If theta is the angle between vectors u and v, then the magnitude of u cross v is the magnitude of u times the magnitude of v times sine of theta, where theta is the angle between the two vectors. The other thing in geometry is that the length of u cross v equals the area of the parallelogram determined by u and v. So we know area is base times height. We can think of the base as the magnitude of u. The height, using right triangle trigonometry, on this part right here, the height is going to be the magnitude of v times the magnitude of sine theta. So if we look at that definition right at the top of the page, that's just the magnitude of u cross v. So the area of a parallelogram defined by the two vectors is the magnitude of their cross product. Let's apply this. So remember that geometric definition, and that the length of the cross product is the area of the parallelogram. Okay, here we go. Find the area of the triangle determined by the points P, Q, and R, then find a unit vector perpendicular to the plane PQR. So we're given points, we're not given vectors. So what we need to do first is find our vectors. Now in this case they're defining a triangle. The formula we have is for a parallelogram. So a triangle is half the area of a parallelogram, so we'll have to divide by 2, use our formula, and then divide by 2. Before we do that, let's find vectors. So let's say our base point is P, point P. So I want to find PQ and PR. PQ, what I'm going to do is do basically Q minus P, component-wise. So I'll get 0 minus 1, 1 minus negative 1, and 1 minus 1. So I get the vector negative 1, 2, 0. PR is basically R minus P. So I get 1 minus 1, 0 minus negative 1, negative 1 minus 1. So I get the vector 0, 1, negative 2. These are the vectors u and v that define our parallelogram, or in this case our triangle. So now I want to find u cross v. So I'll set up my matrix. ijk, and then u in the second row, v in the third row. So if you've tried it, you'll get negative 4i minus 2j minus 1k. And we know that the area of the parallelogram is the magnitude of u cross v. So the area of the triangle is going to be that magnitude divided by 2. Magnitude, we just do the square root of the sum of the squares of our vector components. So negative 4 squared plus negative 2 squared plus negative 1 squared. So we get square root of 21. So the area of our triangle would be square root of 21 over 2. The last thing we're asked to find is the unit vector, or a unit vector, perpendicular to the plane. Now we know that the cross product is perpendicular to both vectors u and v, so perpendicular to both pq and pr. So the cross product is perpendicular to the plane that contains those 3 points. And we just need to make it a unit vector. So we know that the cross product is perpendicular to PQR. Divide by its magnitude to get a unit vector. So we already know its magnitude is square root of 21. So I'll have negative 4 over root 21i minus 2 over root 21j minus 1 over root 21k. And that's a unit vector perpendicular to the plane PQR. Okay, the last thing I want to talk about is the properties of the cross product. So basically how we deal with scalar multiplication, we pull the scalars out. Second property is that you can distribute the cross product. Third property is what we talked about on that second slide, where if you switch the order, it switches the sign. Fourth property is right distribution, so pulling the vector in over addition. Fifth property is if you cross a vector with 0, you get the 0 vector. And then the sixth property is probably a little less intuitive. If you have u cross parentheses v cross w, what you actually end up with is u dot w times vector v minus u dot v times vector w. So those are your 6 properties of the cross product. Once you've finished this video, please watch the second video for section 11.4, which deals with 2 applications of the cross product, which are finding volume of a parallelepiped and finding torque.